Okay, here's problem 15. I accidentally made a mistake, so I'm going to do it again on plain paper. So part A, find the initial height. Initial height is when t is equal to 0. So initial height is 2 plus 20 times 0 minus 5 times 0 squared. So that is equal to 2. Okay, the next question says show the height of the ball after 1 second is 17. So it's a show that. So I need to find the height of the ball after 1 second. So I know the time is 1 second. So I'm going to do h is equal to 2 plus 20 times 1 minus 5 times 1 squared. So h is equal to 2 plus 20 minus 5. H is equal to 22 minus 5, which is equal to 17. All right, next question. So ignore this. That's not the way I'm supposed to do it. Okay, at a later time, the ball is again at a height of 17 meters. Write down an equation that t must satisfy when the ball is at a height of 17 meters. Okay, so if the ball is going to be at 17 meters, that's my height. So 17 is equal to 2 plus 20t minus 5t squared. That's the equation that we need to solve. Now it says solve it algebraically, and I actually did that accidentally up here, but let's do it again. So to solve this, since it's a quadratic, I want it to equal 0. So I'm going to move the 20, I'm going to move everything to the left so that I have positive 5t squared minus 20t. I still have my plus 17, but I'm going to minus 2 from it, so that would be plus 15 equals 0. So I just moved everything to the other side by subtracting or adding it. Now I'm going to factorize it. So 5 times t squared minus 4t plus 3 equals 0. I can factorize inside the parentheses t minus 3 times t minus 1. And then I solve, I get t is equal to, sorry, let's write it out. This is a 4-point question. Let's make sure we show lots of work. T minus 3 equals 0, t minus 1 equals 0, so I get t equals 3 and t equals 1. I already found that one, so the second time that it's again at 17 meters is at 3 seconds. So the answer to this one is at 3 seconds. Okay, to find the derivative. Okay, derivative, dh dt. So notice h is where our y normally is, and t is where our x normally is, so that's why it's dh dt instead of dy dx. So I want the derivative. Let me first copy down the original. H is equal to 2 plus 20t minus 5t squared. The derivative, dh dt, would be equal to the 2 would just go away. I'm left with 20 minus 2 times 5 is 10. 10t, there's my derivative. Find the initial velocity of the ball, that is its velocity at the instant when it's released. So that, again, initial means at time 0. So the velocity is the same as dh dt. So I'm going to do that when t is 0. So 20 minus 10 times 0 gives me 20. So the initial velocity is equal to 20. So it would be 20, and we have units on this, meters per second. That's my initial velocity. All right, when the ball, let's see, find when the ball reaches its maximum height. So when it reaches its maximum height, it's going to stop moving, because then it's going to change direction. So I know that my first derivative is going to equal 0. So if I solve this, I get 20 is equal to 10t, divide both sides by 10, I get t is equal to 2. So at 2 seconds is when it's going to reach its maximum height. Find the maximum height of the ball. So I know that t is equal to 2, so I need to find the height. Height, again, back to the original formula, is this. Am I off the bottom of the page? Oops, sorry about that. Minus 5t squared, so I'm just going to plug in 2 for my t's. So h is equal to 2 plus 20 times 2 minus 5 times 2 squared. I'm making that video. 2 plus 40. 2 squared is 4. 4 times 5 is 20. So I get 42 minus 20 equals 22. So the maximum height of the ball is going to be at 22 meters. Okay, and that is problem 15.